Dear students, welcome to the MOOC course on Solid and Hazardous Waste Management. Today in this module, we will be discussing about landfill leachate and gas management. Now, in the previous module, we discussed about what is a landfill, their types, structure and components. Now, landfill is an engineered structure which is used to contain the waste so that it is not affecting or polluting the different environmental matrices. It is considered as one of the largest route of disposal. They are a planned way of waste dumping or waste loading. It has three main systems or components like a liner system which is spread at the bottom to protect the waste or the leachate, a watery liquid, from entering into the soil. Likewise, you also have a top cover which protects the waste from the air, water and other animals. And here in a landfill, the waste is loaded or deposited in a sequential or a pattern is being followed. One is your cell method, the other one is your layer method and the third one is your area method. Now, these are the different ways by which the waste is loaded by following a pattern within a landfill. Now, during the process of degradation, landfill leachate and gas is generated. Now, what is leachate? Leachate is a watery liquid that is generated during the decomposition of the waste material. Likewise, gas is also generated during the anaerobic degradation of waste material. Now, with this introduction, we will discuss or let us look into the learning objectives of this module. The learning objectives of this module are to understand the process of leachate generation, its composition and characteristics. Then we will also discuss how different factors are influencing the composition of leachate generation. Then we will study about the different leachate collection systems and various leachate treatment options that are available. Further, we will also discuss about the landfill gas, their composition and characteristics. Also, we will discuss about the landfill gas migration and the various factors that influence in migration of the gas. Lastly, we will discuss about how the landfill gas are collected and what are the different treatments that are available for landfill gas that is generated during the decomposition of solid waste. Now, as I told you earlier, landfills are engineered structure for the containment of domestic and industrial solid waste. It is considered as one of the largest route of disposal and it is a controlled disposal option. The waste that is disposed in the landfill will undergo decomposition over a period of time. Now, this is not a specific time, it takes many years to degrade. Now, the decomposing waste releases a toxic liquid called as leachate and a lot of gases during the process of decomposition or degradation. Now, these gases are generally greenhouse gases. Now, leachate is a watery liquid that oozes out from the waste material during its decomposition. Now, it contains a lot of components in the soluble as well as particulate form like your suspended solids and your degraded products. Now, the characteristic of a leachate depends upon the composition of waste, then the presence of biodegradable substance, moisture content, weather conditions, waste holding time and various operational procedures. If the landfill is not properly managed, then what will happen to the leachate? Now, the leachate will slowly seep down and it will enter into the soil and through the soil it will reach the groundwater and finally contaminate the entire aquifer. Now, landfill leachate generation is influenced by a number of factors like your rainfall, landfill cover, waste type, vegetation, climatic conditions and landfill design. When there is precipitation, there will be a lot of water that enters through the waste and this will add to the leachate quantity. Likewise, if you do not have a proper landfill cover, then again the surface water or the rain water will enter into the waste and will increase the leachate quantity. The waste type also influences the quantity of waste generation. If you have a lot of biodegradable material in your landfill, then the waste degradation will lead to the generation of lot of leachate and the leachate quantity will increase. Likewise, your climatic conditions, if the landfill is located in an area where a high amount of rainfall is received, then the leachate quantity will increase. That is how these different factors play a role in modifying or determining the leachate quantity generated in a landfill. Now, the composition of leachate, as I told you earlier, leachate is a toxic liquid which is blackish, orange or yellowish in color. They emit a very strong odor. This odor is attributed due to the presence of certain compounds like hydrogen, nitrogen and sulfur rich organic compounds. They also contain a lot of xenobiotic organic compounds. More than 200 types of xenobiotic organic compounds can be present in the leachate. The major elements, trace metals and other microbiological substances are present both in dissolved and suspended form in the leachate. Now, the pollutants that are present in the leachate can be broadly classified into 4 groups. 1, the dissolved organic matter, which includes alcohols, acids, aldehydes, sugars, volatile fatty acids, fluvic and humus-like materials. Second, it contains inorganic macro components which includes these common cations and anions. Third, it contains a lot of heavy metals and fourth, it contains a lot of xenobiotic organic compounds. Now, this table gives you the composition of leachate. Now, the composition of leachate, as I told you earlier, it varies with age of the landfill. Now, in this table, I have compared the acetogenic and methanogenic leachate. You can see the lot of physiochemical characteristics that are listed on the left side. Now, pH of an acetogenic leachate will be in the range of 5.1 to 7.8. Likewise, the methanogenic leachate will be 6.8 to 8.2. COD is very high. In the initial phases, that is the acetogenic phase, the COD will be around 36,000 milligram per liter, and in methanogenic phase it will be around 2300 milligram per liter, because all the organic matter would be utilized and it results in the generation of gases like carbon dioxide and methane. So, likewise you can see all the parameters, but if you see the ammoniacal nitrogen, which is around 922 milligram per liter in acetogenic leachate, it is almost same in the methanogenic phase. The nitrogen that is present in the landfill almost remains the same and does not show any variation. So, likewise a number of parameters are listed in this table. A lot of inorganic ions, anions, cations, heavy metals are all present in the leachate, and they do not show any much difference between the acetogenic and the methanogenic leachate. The composition of leachate varies depending upon the age of your landfill, pH, nature of waste, decomposition rate and weather conditions. Now, we will discuss each one in detail. Now, starting from the age of the landfill, the composition varies greatly. Now, young landfills that generate acetogenic leachate is different from the leachate that is generated from the old or matured landfill that generates a methanogenic leachate. Now, waste within the landfills, they undergo degradation in 5 different stages. One is your hydrolysis. Now, during the initial period, mostly it is the aerobic degradation that occurs. Now, during the aerobic degradation, there is only a minimum amount of leachate generation occurs. Now, it contains mainly carbonic acid and the pH of such leachate is generally acidic in nature. The second and the third stage, that is the fermentation and acetogenesis phase, influences again the composition of leachate greatly. The major proportion of complex waste is degraded into simpler substances like your organic acid, ammonia and hydrogen. Here the pH of leachate drops below 4, and because of that the solubility of metals increases. The leachate produced during the acetogenic phase, as I told you earlier, they contain a high amount of COD of around 30 to 50,000 milligram per liter. The ammoniacal nitrogen will be around 900 milligram per liter. It is generally contributed by the degradation of proteins and other nitrogenous compounds. It also contains a lot of heavy metals like zinc, cadmium, copper and so on. Now, the stage 4, the methanogenesis phase. Now, the leachate that is generated during the methanogenesis phase, that is stage 4, is generally alkaline in nature because it shows an average pH of about 7.52. This is due to the fact that the organic acids that are generated during the acetogenesis phase are converted into methane and carbon dioxide, which caused the pH shift from 4 to 7.52. Now, the solubility of metals is restricted at this particular pH. Now, the COD and BOD levels of the methanogenic leachate are comparatively less when compared to your acetogenic leachate. But as I told you earlier, the concentration of ammonia that is present there will be same as that of your acetogenic leachate. The next parameter that influences the composition of leachate is the nature of waste. If your landfill contains a major proportion of municipal waste which is rich in organic matter, then the leachate will also contain a lot amount of organic matter and ammonia. Now, the hazardous waste landfills generate a leachate which generally contains compounds like salts, metals, halogenated compounds and other organic compounds. Likewise, if you characterize the leachate that is generated from an inert landfill, you can find only a minimum amount of organic and inorganic species because they are all inert materials. Now, how does the decomposition rate and weather condition influence your leachate composition? Now, during the decomposition process, when the water seeps in, it creates an anoxic condition. Now, during this anoxic condition, which is created by the bacteria and fungi, a lot of oxygen is consumed. Now, the waste pH drops and this results in the dissolution or increases the solubility of metals in the leachate. Now, the waste undergoing decomposition process also release water which adds to the volume of leachate. Now, let us discuss about how to estimate or what are the factors that you will look into while estimating the leachate generation, or in short, to calculate the amount of leachate generation, what are the factors that you will look into. Now, the factors used for the estimation of leachate will be: 1. Amount of rainfall, you should know what is the amount of rainfall that is occurring. Second, the rate at which the rainwater is infiltrating or percolating through the landfill. Third, you will also discuss about what is the potential of waste to absorb this water. Then you will discuss about what is the amount of liquid waste that is disposed into the landfill along with the other solid waste materials. Then we will also take care of the weight of the waste after the absorption of water. Finally, leakage via seepage or discharge should also be accounted. Now, let us discuss how the leachate can be managed. Now, generally the leachate that is extracted from the landfills are stored in evaporation ponds. Now, these evaporation ponds are generally lined with a synthetic or a natural liner, that is a clay liner. Now, once they are lined, now leachate will be extracted and added to this pond and left for evaporation. Now, after evaporation, the sludge that is generated will be taken back and then put back onto the landfill. After you add the leachate into these ponds, the floating aerators are introduced into this pond. This will minimize the odor generation and will also prevent the anaerobic decomposition that will occur within this pond. Now, let us discuss about the various components of the leachate collection system. The components of leachate collection system includes pumps, manholes, discharge lines and liquid level monitors. The overall efficiency of the system is generally governed by your liner system, filters, pumps and sumps. Now, let us discuss about each of these components in detail. First is your liners. Now, liners are generally used as both leachate collection and a separating device. Now, liners can be natural or synthetic. It is generally used to protect the soil and groundwater that is present underneath from the leachate entry and further contamination. Now, the liners, they should be always strong, flexible, impermeable, they should possess a very high tensile strength, should be tolerant to temperature fluctuations and should be black in color to resist UV light. They should be easy to install, they should be economical and resistant to scratches, chemical degradation by leachate. The commonly used liner materials are geomembranes, geosynthetic clay liners, geotextiles, geonets, geocomposites and geogrids. Now, each of this we have discussed in our previous modules. Now, next is your leachate drainage system. Now, the leachate drainage system is used to collect and transport the leachate which is collected inside the liner. Now, the pipes of the drainage system are located at the bottom of the cell. The pipeline network of the drainage system can be flexible or rigid, but the joints that are connecting these pipes should be always flexible so that it can hold the weight and pressure of the waste that is loaded above that. Now, the collection pipe drains, collects and transport the leachate throughout the drainage layer to a collection sump where it is generally separated for further treatment and disposal. Now, the pipe network helps in draining the waste within the drainage system to reduce the mounding of leachate. These pipes are generally fabricated with cuts and are inclined at an angle of 120 degrees. This will prevent the entry of solid particles and further choking of your pipe network. Next is your filter. Now, the filter layer is used on top of the drainage layer in the leachate collection system. Generally, granular and geotextile material are used as two major filters. Now, what they do is they prevent or avoid the entry of coarser materials into this leachate drainage system and protect their blocking. The granular filters come with one or more soil layers which have coarse gradation in the direction of leakage so that the soil is protected from leakage of leachate. Then sump. Sump is a place where the liquid that is generated from the landfill is stored. When the liquid that enters through the landfill cell, it slowly progresses down the filter, then through the pipeline and finally it comes in the sump. Now, for efficient operation, the number, location and size of the sumps is very important. The size of the sump will always be larger in areas where you receive very high amount of rainfall. Now, larger the pump capacity, smaller should be your sump size. Now, it is vital for always your sump should be designed in such a way so that it should accumulate the expected amount of liquid that is being pumped from the leachate collection system. Then comes your membrane which is used as a filter. Now, some landfills are equipped with certain forms of membranes to separate the waste from the surrounding area. The leachate collection pipe network is generally laid on the membrane. The membranes are generally porous to some extent because with time a low volume of leachate crosses the membrane. Now the leachate that is collected from the landfills can be re-injected back into the waste or recirculated back into the waste mass. Now, by doing so, what will happen is you can maintain the moisture condition that is present in the waste loaded in the landfill. Now, when the moisture conditions are optimum, the waste degradation fastens up and then the performance becomes better. Also, the leachate recirculation will add extra inoculum or bacteria back to the landfill. Also, the partially degraded material which is present in the leachate, when you add it back into the landfill, they will undergo complete degradation. That is one advantage why leachate that is generated can also be re-injected back into the landfill. So, as I told you, these re-injection process generally increases the decomposition and gas production rate. Also, it converts the leachate volume into landfill gas. Thereby, the overall volume of leachate that is generated will be reduced. Now, what are the different treatment methods that are available for your landfill leachate? Now, the landfill leachate can be treated by both physiochemical and biological methods. Now, before subjecting it to any of the biological or physiochemical process, the leachate will be collected from the sump into a treatment container and mixed with certain chemicals. Now, these chemicals are generally used to adjust the pH and coagulate and settle down the solids. This will also reduce the concentration of hazardous material that is present in the leachate. Now, let us discuss about what are the different biological and the physiochemical methods that are used for leachate treatment. There are a number of biological methods that are used for leachate treatment. One is your activated sludge process, second rotating biological contactors, sequencing batch reactors, reed beds and biologically aerated filters. Generally, microorganisms are used for treating the leachate in these processes. Now, activated sludge process, you subject the leachate to a mass of microorganisms and then convert them into biomass and help in degradation, and the effluent that is coming out of the aeration tank can be settled down in a secondary sedimentation tank, and the effluent can be further subjected to tertiary treatment. In rotating biological contactors, it consists of a huge disc where it is partially immersed in a tank containing the leachate. Now, the disc keeps rotating. When it comes in contact with the leachate, it will take up the substrate. The microorganism that grows on the disc takes up the substrate from the leachate, and once it goes turns back and goes outside, it gets exposed to the atmosphere from where it gets the oxygen. Likewise, the sequencing batch reactor is also a biological reactor where again the leachate is subjected to a mass of microorganisms and treated. Now, reed beds is where plants are used to treat the leachate. There are plants like Typha, Phragmites, they are all used for converting the pollutants that are present in the leachate into simpler ones. Finally, biological aerated filters are also used as a biological method for treating your leachate. Now, let us discuss about the various physiochemical treatment methods that are available for leachate. The various physiochemical treatment methods available for leachate include adsorption, membrane technology, ammonia stripping, chemical treatment, coagulation, precipitation, chemical oxidation and so on. Now, adsorption is a process where the pollutant that are present in the liquid phase is converted into solid phase. Many adsorbents like your activated carbon, synthetic polymers, silica based adsorbents are used in the adsorption process. Now, it is generally used as an advanced wastewater treatment process. Now, PACT, called as your powdered activated carbon, it is used as an adsorbent in activated sludge bioreactor. In an activated sludge bioreactor, you add the powdered activated carbon and then it is this will absorb the toxic contaminants that is present in the leachate. The adsorbed sludge will then be incinerated to destroy the organics. Now, for adsorption process, pre-treatment is required because once the suspended solids are not removed from the leachate, it will clog or affect the adsorbents. So, generally you have to pre-treat and then subject it to the adsorption process. The second one, the membrane technology, it is generally used in the final or the polishing step. Microfiltration, ultrafiltration and reverse osmosis process are generally used. They remove dissolved inorganics like your metals, cyanides, ionic species, high molecular weight organics like your pesticides are removed from the leachate. Just like your adsorption, this here also pre-treatment is required. The chemical treatment is used where certain chemicals are applied to detoxify and remove the harmful constituents that are present in the leachate. Now, the chemical methods are generally fast and they do not cause any damage to the setup. Some of the chemical methods are the coagulation and precipitation, chemical oxidation and ammonia stripping. Now, in coagulation and precipitation, generally you use certain chemicals to precipitate or coagulate that harmful toxic pollutants which are present in the leachate. Now, these precipitates will then be removed by sedimentation. This treatment method will be generally used to remove high molecular weight organic materials like your fulvic and humic acids. Now, chemical oxidation is another chemical treatment method where the waste is subjected or undergoes oxidative degradation and further gets transformed. Now, a variety of chemical oxidants are used like your hydrogen peroxide, ozone, chlorine will be used. Here a point to remember is when you select an oxidizing agent, you should check its oxidation ability and then select them. Because higher the oxidation ability, better would be the oxidation process. This method is generally a preferred technique when you have low BOD to COD ratio, which indicates low biodegradability of your landfill leachate. Now, oxidants like your chlorine, potassium permanganate, ozone and calcium hypochlorite are popularly used in chemical oxidation process. The ammonia stripping process is where large quantity of air is passed through the leachate. Due to partial pressure of the ammonia gas, the ammonia in the liquid phase gets converted into the gaseous phase. Now, stripping towers are generally more effective since there is better contact between the gas and liquid phase when dispersion of liquid takes place in the form of fine droplets. Dear students, in the first part we discussed about the landfill leachate generation, its composition and how the different factors like age, decomposition rate and all is influencing the composition of your leachate. Then we discussed about the different characteristics, then we discussed about the different leachate treatment collection components and the treatment technologies. Now, in this part we will be discussing about the landfill gas. What are its composition, its characteristics, about the landfill gas migration, what are the different systems that you are going to use or by which you are going to collect the landfill gas, and finally we will discuss about few treatment technologies. Now, the landfill gas is generated when the waste that is contained in the landfill is undergoing a lot of reactions. During the biological decomposition, they release a lot of gases. The landfill gas is a product of methanogenic phase. The gases that are produced include methane and carbon, which are the major constituent of the landfill gas, and the minor constituents are nitrogen, carbon monoxide, oxygen, ammonia, sulfides, hydrogen and other non-methane organic compounds like your trichloroethylene, benzene and vinyl chloride. The landfill gas that is generated is generally affected by a lot of factors like your temperature, moisture, waste composition, etc. Now, higher the temperature, more would be the gas production because more would be the biological decomposition of the waste. Now, moisture, appropriate moisture should be there. If moisture is less, then the waste degradation will be delayed and gas generation also will be less. Likewise, waste composition, if more amount of biodegradable material is present, then the gas generation will also be high. Now, this table gives you the composition of landfill gas. You can see methane is a major constituent of the landfill gas, which constitutes to about 63.8% of methane and 33.6% of carbon dioxide. Now, oxygen is very less of about 0.16%, nitrogen is 2.4, hydrogen is 0.05. Now, other gases are present in the trace level like your carbon monoxide, ethane, ethene, acetaldehyde, propane, butane, helium, alkenes, etc. Now, generally if you see unsaturated hydrocarbons, halogenated compounds, hydrogen sulfide, organosulfur compounds, alcohols are also present as part of your landfill gas. Now, the landfill gas is generated by three different processes within the landfill. First is your microbial decomposition, second is volatilization and third is chemical reaction. In microbial decomposition, a major amount of gas is produced. Now, here the organic waste is subjected to microorganisms, they degrade the waste and generate a major proportion of gas. The microorganisms can be present either in the waste material or in the soil which you add or use it as a cover or liner material. The biological degradation of the organic waste occurs in different stages and depending upon that the composition of gases also change with every stage. Now, volatilization is the second type of process that helps or releases gas. The process of volatilization is nothing but the conversion of solid into a liquid or gaseous phase. Now, here landfill gases like non-methane organic compounds are generated. Now, chemical reactions also result in the formation of landfill gases. Example, your ammonia and chlorine react to generate the harmful gas. Now, this table summarizes the landfill gas generated by various biodegradable components of the waste material. For example, if you have high amount of carbohydrates in your waste, that results in generation of around 829 meter cube per ton of waste. If you have proteins, that generates 988 meter cube per ton, and fats generate 1430 meter cube per ton. So, depending upon the proportion of these compounds in the waste, the amount of gas production will also be higher. So, carbohydrates results in 50-50, like 50% carbon dioxide is generated and 50% methane. Proteins produce a slightly higher amount of methane, like 51.5% methane and 48.5% of carbon dioxide. But fats, if you see, they generate more amount of methane, like 71% methane and 28.6% carbon dioxide. A typical waste will generate around 300 to 500 meter cube per ton of gases. Now, in the process of degradation within the landfill, there are many different stages of bacterial decomposition occurs. This we have discussed earlier in our previous module and also in this module. Now, there are 5 stages. Stage 1 is hydrolysis or aerobic degradation, stage 2 is your hydrolysis and fermentation, stage 3 is acetogenesis, and stage 4 methanogenesis, and last stage is oxidation. Now, in the first stage, hydrolysis or aerobic degradation, the gases that are produced are carbon dioxide and water. The second stage, you have a lot of organic acids that are being generated. In stage 3, hydrogen and carbon dioxide is generated. Now, in stage 4, methane and carbon dioxide is generated, and in the stage 5, which is the last stage, again where oxidation or aerobic organisms start building up, you can find carbon dioxide generation. The initial stage, I mean stage 1, and the last stage, stage 5, you have carbon dioxide, more amount of carbon dioxide generation, because there the aerobic microorganisms play a role. From stage 3 to stage 4, it is the anaerobic microorganisms, and that is why you see generation of hydrogen and methane with little amount of carbon dioxide. Now, in this figure you can see what are the different gases that are produced and how these gases vary from stage to stage. If you talk about oxygen, in the first stage it is high and slowly it decreases at the end of stage 1, and it again picks up, and you can find the presence of oxygen in the stage 5. Carbon dioxide slowly increases in the mid of stage 1, and it increases and peaks out at the end of stage 2, and after that it reduces and becomes stable till stage 4 and further decreases in stage 5. Nitrogen, once again it is very high in stage 1 and slowly it decreases gradually till stage 3 and finally ends up. Hydrogen production begins at the end of stage 1 and it peaks out at the end of stage 2 and slowly decreases and drops down or becomes 0 at the end of stage 4, where your methane generation actually picks up. The methane gas again starts its generation at the end of stage 2, slowly it increases and peaks out in the mid of stage 4 and it becomes stable, and at the end of stage 4 it decreases and becomes 0. Now, let us discuss about what are the different conditions that are affecting or influencing your landfill gas generation. First is your waste composition. Now, higher the organic waste, higher would be your landfill gas generation. Now, in chemicals, if you have high amount of chemicals, then you will have higher generation of non-methane organic compounds by the process of volatilization or chemical reaction. Now, the second factor that influences is your age of refuse. Now, the waste that is more than 10 years old will generate less amount of landfill gas. Now, the maximum amount of landfill gas is generated between 5 to 7 years of waste loading. Now, the presence of oxygen also inhibits your methane production or alters your composition of gas indirectly. The next factor that influences your gas composition is your moisture content. Now, moisture content generally promotes certain chemical reactions and they facilitate more gas production. Now, microbial degradation also is enhanced by the moisture, which generally leads to increased gas production. Temperature is another factor which accelerates microbial activity and results in the increased amount of gas generation. Now, higher temperature will always lead to process like volatilization and other chemical reactions. Now, let us discuss about the characteristics of landfill gas. There are many different characteristics. We will discuss about density, viscosity, heating value, water vapor and the non-methane organic compounds that are present in the landfill gas. The density and viscosity. The quantity of individual gases are generally determined based on the concentration of landfill gas. For example, if you have a mixture of 90% carbon dioxide and 10% hydrogen, which is generally produced in the first stage of anaerobic phase, this will be heavier when compared to air. Likewise, a mixture which contains 40% carbon dioxide and 60% methane, which is generally produced during a methanogenic stage, it will be lighter when compared to air. Now, the heating value of landfill gas, if you see, it is around 500 BTU per feet cube. BTU is nothing but British thermal unit. Now, this is half the value of natural landfill gas. The actual heating value of landfill gas generally depends upon the age of the waste and type of landfill cover. The non-methane organic compounds, they contribute a major proportion if the waste that is present in the landfill is municipal solid waste. Now, the gas will contain 50% methane, 50% carbon dioxide and some amount of non-methane organic compounds. The concentration of these compounds will generally vary from 200 to 15,000 milligram per liter. Water vapor is also present in the landfill gas, and the landfill gas that is generated during the decomposition of waste will generally contain about 4 to 7% of water vapor. Now, the quantity of water vapor is a function of temperature and pressure. Now, when the temperature is elevated, your bacterial activity will be high, and during the when your bacterial activity is high, that will increase the evaporation of water and minimize the amount of water vapor that is present in the landfill gas. The other characteristic is hydrogen is also produced during the process of anaerobic degradation within the landfill. Hydrogen is a flammable gas, and around 4 to 74% of hydrogen is being produced. Now, this hydrogen is generally consumed in the methanogenic phase to produce methane. Now, let us discuss about what is landfill gas migration. The gas that is produced in a landfill, they do not remain idle. They keep moving, they keep migrating and fill up the void or pore spaces which are available in the waste material. Now, the methane, which is generally lighter than air, will travel vertically and reach the surface of the landfill. The upward movement of gas is generally inhibited or hindered by the overlaying waste or the cover material. During such conditions, what will happen is the air will move horizontally to find any weak area which is there in the waste material, and from that weak area it will move upwards. Now, the gas generally use material of least resistance to travel across, like your sand or gravel are some of the examples. Now, carbon dioxide is collected in the subsurface due to the density difference. Now, the migration of gas is affected by a lot of factors. First, diffusion. Landfill gas moves and spreads to the surrounding area through the process of diffusion. That means, the gas moves from a higher concentration to a lower concentration area. A high pressure zone is created when the gas accumulation is high in a particular area. Now, accumulation generally occurs due to compaction of your overlying waste. Now, the variation in pressure will generally result in the movement of gas from high to low pressure areas. Now, increase in gas concentration will increase your subsurface pressure and it will be higher than the atmospheric pressure. Now, when it is higher than the atmospheric pressure, what will happen is the gas will be released into the atmosphere. The other factor that influences the migration of gas is the temperature. Now, when temperature increases, gas diffusion and rate of migration also increases. Now, when the soil is frozen, they act like a physical barrier and they will not allow the upward movement of landfill gas. The other parameters that influence your gas migration is your landfill cover, type and permeability. Now, material used in landfill cover influences or should influence the migration of gas. Higher the permeability, more easily the gas will migrate. For example, sand and gravel which has higher permeability will facilitate more gas migration when compared to clay and silt which has less permeability. Now, there are also other natural or cultural pathways that a landfill gas takes to escape out of the landfill. Now, the natural cultural pathway is nothing but your natural geology or man-made structures. If you have any fracture, fault or fractured rocks or any porous rocks, then they will influence the migration of gas. Likewise, if you have any drains, trench, vents, pipelines, tunnels which are generally man-made structure, they will also influence your landfill gas movement. Now, wind speed and direction will also influence your gas migration, because wind carries the landfill gas, because wind mixes with the gas and carries it from one place to another. Now, moisture, the gas accumulated within the pores are pushed out by the rainwater. So, when there is rainfall, rainwater occupies these pores, and when they occupy the pores, they will push out the gas and the gas will be released outside. So, wet soil in the cover does not allow gas to escape out from the surface. Now, groundwater levels also influence your landfill gas migration, because when the water table rises, the gas moves upwards and will try to escape out of the landfill cover. Now, let us discuss about the landfill gas collection. Now, landfill gas control systems, they generally include collection, conveyance and treatment. An ideal system will generally consist of a sequence of gas collection wells which will be generally located or positioned throughout the landfill area. Now, the gas collection wells will be designed based on the volume and the density of waste depth. Now, the gas collection wells will be designed based on the volume and density of waste, depth and the area of landfill. Now, collection wells in the landfill will generally offer paths for the movement or passage of gases. The gas will be either discharged directly to the atmosphere, or it can be collected and treated, or it can be used potentially to avoid any health and environmental risks. There are two gas collection systems which are available. One is passive gas collection system and the other one is active gas collection system. The passive gas collection systems are generally established either during active operation or after the closure of landfill. Now, collection wells or extraction wells are used in passive systems for gas collection. Now, these wells will be generally made of perforated plastic material which is mounted either vertically throughout the landfill up to a depth of about 50 to 90% of the landfill waste thickness. Now, if there is groundwater, then what should you do is the wells will be should be terminated at the groundwater table. Now, these passive collection system can also contain horizontal wells to facilitate passage of gas through the landfill. Now, these horizontal wells are more suitable when you need to recuperate gas rapidly. Now, gas movement can also be controlled with the help of liners on the top, sides and at the bottom of the landfill. Now, an impermeable liner will generally trap the landfill gas and will generate an ideal gas passage pathway. Now, the efficiency of a passive collection system will depend upon the way it is controlled and other environmental conditions. Now, when the pressure is not sufficient enough, it will not drive the gas up to the control or venting device. By this way the passive system will fail. Now, in case of high pressure, what will happen is the outside air will enter inside the landfill through these passive vents, and this will not direct the gas to the control device. Therefore, the passive collection system are not consistent enough in especially in areas where you have high risk of gas migration. The other type of gas collection system is your active gas collection system. It is a most effective system, and it consists of both vertical as well as horizontal collection wells. Unlike your passive collection system, the active system, they have valves to control gas flow and provide it to a sampling port. Now, The active collection system consists of vacuum or pumps which generally pushes out the gas out of the landfill. Now, the gas generally migrates in the direction of low pressure region, which we have already mentioned earlier. Now, the gas migrates in the direction of low pressure, which we have already discussed earlier, because the gas migrates through the process of diffusion, which is nothing but movement of gas from a high concentration area to low concentration area. Now, let us discuss about the different landfill gas treatment methods that are available. Basically, there are three different treatment technologies. One is combustion, the other one is non-combustion technology, and the other one is odor control technology. Now, combustion technology, here you use flares, incinerators, boilers, gas turbines and internal combustion engines to thermally degrade the substance that is present in the gas. Now, combustion technology converts methane into carbon dioxide and thereby reduces the risk of greenhouse gas emission. Now, non-combustion technology, they are of two types, one energy recovery technology and the other one is gas to product conversion technology. Here the landfill gas is converted into energy and commercial products like the compressed gas, natural gas like CNG, methanol, purified carbon dioxide and methane, liquefied natural gas and other products. Before subjecting the gas to the non-combustion technology, you have to pre-treat them to remove the impurities like the non-methane organic compounds, water, carbon dioxide and so on. The last method of gas treatment is your odor control technology. It is generally used to prevent the odor that is generated during the gas escape from the landfill. The top cover restricts the odor from being released out of the landfill into the open environment. Now, extensive covers can be used to restrict the moisture from leaching into the waste and promote bacterial growth and decomposition, because the gas is generally generated during this process. Also, you can plant some vegetation on the cover which will also decrease the odor. The process generally helps in eliminating the odor from the landfill gas by combusting the odor causing gases thermally. Now, venting of landfill gas with the help of filter can also decrease the odor that is generated during the landfill gas generation. Now, lastly, let us discuss about what are the benefits of the landfill gas. Now, landfill gas can be used as a source of energy. It can help in conserving other energy resources. They can provide economic benefits to the people. They will decrease the risk of global climate change. Used on site by using boiler or any other type of combustion system which will generally provide heat. Also, with the help of micro turbines, steam turbines or fuel cells, you can generate electricity from the landfill gas. The landfill gas can be collected and sold off site through other natural gas pipelines. Now, landfill gas can also be used for the evaporation of leachate that is produced as a byproduct of the reactions that occur in the landfill. To summarize, at the end of this module, we have discussed about the landfill leachate and landfill gas. Under landfill leachate, we have discussed how leachate is being generated, how its composition is being varied by different factors like age of landfill, decomposition rate and so on. Then we discussed about the different landfill leachate collection units that are present and the different treatment technologies like the biological treatment technologies and the physiochemical treatment technologies that are available. We also discussed in detail about these treatment technologies. Then in the second part, we discussed about the landfill gas, its composition and characteristics. Then we also discussed about how different factors are influencing the landfill gas generation. Later, we discussed about landfill gas migration and what are the factors that influence the movement of gas from one area to another. Then we discussed about different gas collection units like your active and passive gas collection systems, and finally, we discussed about the different treatment options that are available for the landfill gas like your odor control technology, combustion technology and non-combustion technology. I hope you would have enjoyed this module. Thank you.